we're now going to have our presentation by Nikhita Singh. Nikhita is a master's in media arts and science from the Massachusetts Institute of Technology. She was also a researcher at the Personal Robots group at the MIT Media Lab, where she designed and studied social intelligent robots and AI platforms. And now she's a co-founder and chief product officer of Artificial, she's going to talk us more about her background. And we also know that she's a master expert in crosswords. So I'm not sure if that will come up during the presentation. So Nikhita, please take it away.
Thank you guys for having me and for spending an hour together. So as Miguel mentioned, I thought it'd be a good opportunity to talk about this tension of academia versus industry, because it's something that I've certainly oscillated in back and forth many, many times in my life. And so for me, as my background, so currently as Miguel mentioned, is co-founder and CPO of a startup that's building automation tools for biotech labs. But in that process,
you just we're seeing your Zoom window, so if you can just please
oh yeah, get rid of the is that okay now? Is that good? Okay.
We're still seeing the now it's perfect.
Okay, I'll move it back out. Cool. So my background, I think I oftentimes since graduating from the Media Lab have actually been asked about my experience in academia versus industry. And so this talk was really relevant because I was reflecting on all these conversations that my friends asked me to have with folks that were thinking about graduating. And so, really the big tension that I often felt was that I loved the allure of academia where I could go and work on these like really awesome 30-year vision problems and go technically very deep. But then I also loved the idea of being able to deploy within industry and have access to like hundreds and thousands of robots that I could put into the world. And so that perpetual existential crisis essentially amounted to a lot of oscillation between the two. And I originally thought that I would be a scientist. I worked in an immunology lab, was convinced that I would do like an MD PhD and work on surgical robots. And so I started to trade babysitting when I was really young for getting a postdoc to teach me how to do things in surgical robotics and in immunology. And then decided to go to college to pursue that goal, but then really like after 3 months realized that I hated it. And so I dropped out for a year and took the time to reflect on what I wanted the new vision for my life to look like. And so I spent a bunch of time in a surgical robotics lab. I saw a professor, Ken Goldberg, who is at Berkeley, and I saw that he was dabbling with robots in all these different ways, from like, needle steering to picking to robots that do art. And I felt like at the time for me, if, it let me not make a decision as to what I really wanted to do. So I picked the most general way to like approach robots that I possibly could, and spent 4 years working in that lab while doing my undergrad, and really going deep on robotics problems. And I think coming out of it, the reflection that I had for myself was that I wanted to see things in the real world and see how they manifest. And so I ended up joining Palantir at the time, which was pretty small back then compared to what it is today, and essentially spent 3 years flying around to different places in Europe and the US, working on very data-oriented problems. And something that stuck with me was that, as a hopeful, optimist graduate, I was convinced that I could solve all these like fundamental data issues with, AI and next level modeling. And then a lot of the project was spent writing SQL queries to connect databases that weren't actually connected. So it forces you to realize that the brass tacks of actually getting something to work and run in the world is very different, and laying that foundation is so critical to being able to layer the fun academic applications that I was really passionate about. Coming out of that, I ended up going back to academia. So I went to the Media Lab in the Personal Robots group and spent a few years working on more of the human.
9:15 हो गए हैं और मुझे अभी realize हुआ कि मेरी
on the human robot interaction problem. And then ultimately that led to pivoting back to industry and starting a company called Artificial, which is really around making robots and automation more accessible in the lab. So, in showing this path, I think when you see it in a pretty slide, it looks a lot more put together than it was. I think at the time, a lot of those decisions felt a little bit like this, where you're constantly wondering, am I doing the right thing? Am I actually moving away from my goals? And if I leave academia, will I never be able to go back? And so there's definitely this like perpetual tension that I think I had to face as someone who wasn't taking the linear track from one place to the next. And so, as with any good revisionist history, I was reflecting back on this while making this slide deck, and I realized that the chapters in the way that I approached the robotics problem really fell into these 4 key phases. The first part of my life was really about making that robot circle better. So like the technically difficult problems, leaning into making the robots more accessible, more usable, all sorts of kind of more deeper problems in that space. And then I really wanted to then bring the world of robots and people closer together. And that was a lot of what I did at Media Lab. And then as soon as I hit industry, there was this realization that robots and people are rarely together in the real world. And oftentimes they in fact have a literal barrier in the form of a safety fence. So I felt like intellectually very much not fascinated by that reality, having just tried to bridge the two in a really nice Venn diagram. And so what I hope to accomplish in chapter 4 in my current world is to bring that circle a little bit closer, fully knowing that I can't get to the level of chapter 2 yet, but can I actually start to move them closer in the way that's possible. And so I wanted to use this as a frame for talking about the robotics problems that I worked on and kind of what I learned from each one to end up where I am today. So the first chapter, as I mentioned, was really about making that robot circle richer. And so I think, as an optimistic undergrad and someone coming at really young, I was like, I'm just excited that things move in the world, and I wrote code to make them do that. And so I worked on a bunch of things like a autonomous driving Lego robot, which was really silly, but awesome and fun, and taught me a lot about all the different components of a robotic system. I helped on projects with needle steering or trying to get a Da Vinci robot to do surgery, and then got to dabble with some universal robot arms doing some basic picking things. And really my contribution to all of these projects was minimal, but it gave me a deep appreciation for the idea that robotics is in fact one of the few things that is very, very much a team sport. You cannot build a robotic system end to end without having folks from a multitude of different spaces. And I think that was something that resonated with me a lot because it took away the burden of I have to know it all, right? Which is great for a type A personality in a way. And you realize that, you do in fact have to lean on a whole group of people to get this system and this thing to actuate in the real world in a reasonable way. And so taking that learning, chapter 2 really became about how do I bridge this world of robots and people in a more intimate and close way. And so a lot of the work I did at Media Lab was around social robots. And so that's Jibo, as I'm sure many of you are familiar with, interacting in an old age home. And so we worked a lot with older adults. We worked on how, a social robot could help in their day-to-day. It could help support social connection with their families, and really exploring the relational elements of how robots and people interact. And so my thesis ended up being on voice-based agents. And so I looked at things like Google Home or Alexa and Jibo, and how having social capability changed the way that people related to these agents in their day-to-day life. And I think one of the things that stuck with me, because a lot of this work, was funded by industry. I worked with both. I created participatory design kits for different industry companies. It was that there is this blend where academia and industry can intersect. And so there is potential to create and work in that intersection itself. And so with this project, we spent 2 years with a group of about 100 folks from age 5 to 98. And we deployed all these agents in the home, and we started to explore how people interacted, how their relationship with the agents changed over time. And it was really about this idea of like deployment and understanding over a longitudinal thread. And so these ideas stuck with me a lot and kind of got to explore the same notion with things like robots as tutors in the school. So this was a project the Personal Robots group did, where we deployed these robots in schools over a long period of time. All of us would go and run some of these studies. And so really getting to dig into these behaviors. And this was an example of a project where we were looking at storytellers and listeners and trying to see how you could build out back channeling behaviors in the robot to support this interaction. But I think in all of these pictures, what you see is the people and robots are really close together. And I think the part that stuck with me was that in all of these applications, we have this wonderful idea of what we want robots to be in our day-to-day life. Part of that is informed by pop culture. Part of that is because, an old mentor of mine used to say, like, we are fascinated by robots because they're reflections of ourselves. And so there's this kind of idea that like, we want them to play these bigger roles in our lives. And then there's the reality of what they're capable of doing today. And that massive gulf in the middle hasn't been bridged. And as a result, you're constantly in this tension of, I want to curate this interaction, but I'm not able to do so. And so what I measure about that interaction, I don't know what value it holds to me because it wasn't curated the exact way I wanted it to be. And so I think, that tension that I felt was the impetus for figuring out that I wanted to go back into industry and see how these robots were interacting in the deployed and real context to get some of that intuition and bring it back to what I thought would probably be a PhD in a few years, actually. And so I think with that tension in mind, I decided to go looking for jobs in industry that were around robots. And I was promptly disappointed because most of them were about like the UX of picking objects in a bin or something that I really did not care about. And so I think this is like a tension that people often feel because, especially as someone who wants to do UX design, a lot of your jobs look like changing the color of an LED on an Alexa ring or, like these very like trivial interactions. And not to say that, any of that isn't important, but when you read the job description and like imagine your day-to-day compared with the fantasy land that academia can offer, that can feel like deeply disappointing to a person. And so, I ended up joining at the startup exploration, which was 2 people. They were like incubated out of a VC firm, and they had this grand vision of building a robotic platform that would be better than all of them, right? So it's like, what is the next ROS? We can open source it and build this dream. And so when I joined, the first thing we had to do was go and figure out which part of industry we wanted to launch this platform in. And so I started visiting all these different factories and like places to figure out, what would be a good spot for this platform to be deployed. And most of what you find in industry with a ton of robots looks like this, where it's like a fixed room, it's a closed box, it's either behind a safety fence, and there are no people around. So it was a stark contrast to the photos I showed you earlier, where people are very close to the robots themselves. And so this really felt disappointing to me in a deep way. And I think I kind of felt like, well, what is the point of building a platform when, who's going to use it? Like, I don't really care about this scenario on a personal level. I think from there, we started exploring the idea of cobots and like this emerging set of tools that, do coexist with people. And so we visited all of these small, medium-sized kind of factories that had invested in things like this universal robotics arm and started talking to folks. So in that year, I must have talked to about 250 people who were using robots in their day-to-day life and trying to understand what use and purpose they served in, their kind of particular application. And so something that stuck with me is that often in these more unstructured environments, there's a novelty to the robot and people get really excited the first 6 months they have it and they program it, and then it starts collecting dust in a corner. And so for you as a designer, that can be both deeply motivating because you're like, how can I make this better? That seems like the perfect problem for me to work on. But it can also be really demotivating because you're like, well, the reality is that someone has to know how to program, probably some like C#, and like it's unlikely that I'll be able to make this way better for this person to use in this environment. A project that came up that actually became really inspiring for me to connect back to the academic roots was this autonomous cart. So this was an investment that the same VC firm had made, and we had one of these carts laying around in the office. And so we started to build out a bunch of tools for it so it could deliver coffee and boba around the office in very typical Silicon Valley style. But I think getting to do that where, you know, how does this cart navigate an office with 300 people? How does it tell me what it's doing right now? How can a person have confidence that it's not going to run them over? Became this kind of mini challenge that we took on. And so it allowed me to kind of connect with those roots that I had about, you know, even in this simple case of a cart that's moving around a human environment, these same ideas of movement, of how you express intention, of how you create a digital twin and map of where it's going, how can you use interfaces like an iPad or natural language all start to show up. And so it became kind of exciting for me to say, like, this is interesting. What if I could start to bridge these worlds and explore these ideas in more unstructured ways? And I left that with the insight that, you know, when you put robots, people in an unstructured environment together, it is a struggle bus. And that's probably why you don't see a ton of companies that are attacking this particular set of problems in the world. So, you know, like anyone with slightly masochistic tendencies would, I was like, cool, let's take this on and see if we can make this work. There seems to be enough funding in the VC world. Maybe we can, you know, buy us enough time to try to make this a reality. So I started to work on, you know, looking at spaces that were unstructured. And I think the reality that really stuck with us at Artificial was that on the top left, you see car manufacturing in the 1930s, and then on the right, you see it today. And so car manufacturing is great. You can push out a car, many of them a day. Those robot arms look awesome, and people are mostly used for maintenance in that process. In the bottom, you see a lab with Alexander Fleming in the lab trying to do experiments on penicillin. And this is the lab today. And, you know, people sometimes joke with this picture that the only difference is that there's no cigar in the lab on the right. Other than that, lab work looks very similar. And for me, like coming back to this after not having spent 15 years in a biotech lab, it was really telling to say like, wow, I mean, I've seen all these great robots in like factories. I've seen curating robots for the home. Why is it that a scientist can't run an experiment on a robotic system in an easy way in their day-to-day experimentation? So I think this was like a picture in reality that stuck with me. And we spent months going and talking to all sorts of different labs in the space and trying to understand why this friction exists. I think to give you kind of a view of what, you know, a lab looks like, right? This is an example of one of the labs we visited, which is at the cutting edge of automation in the biotech space. And so you see that it like does not look like a factory. There's a ton of things around like plates and tubes and, you know, like different pieces of equipment. And you have a robot arm that's essentially taking plates from one box and moving them to the other to run the actual experiment. So this reality to me was like really compelling, right? Because you have a lot of structure in some ways, like plates are standardized, tubes are standardized. The robot is just a SCARA arm that needs to move like a rectangular plate around. But then at the same time, the scientific process is inherently about improvisation. It's about flexibility, it's about iteration. And so encoding all of that art form into robotic systems is incredibly difficult, especially when the pace of that can evolve so quickly. So this kind of leads me to what I often joke is the expensive paperweight problem, because I had one of our customers refer to robotic systems in this way, where he was like, yeah, totally, I'll spend $1 million on a robotic system, but it generally ends up being in the basement in a corner collecting dust, like an expensive paperweight. And so I think this reality is very much true, especially of robotic systems and environments that need flexibility, that need a lot more improvisation in their process. And the reason it's really hard is that, if you look at a lab, every single piece of equipment needs its own special software. There's incomplete ontologies, so no one has encoded all the nouns and verbs of a lab such that you can build software that supports this ecosystem. Most people don't consider the scientist as part of the loop. And so you either solve the robotics problem or the people problem, but you never try to bring those together. And scientists can't code when it comes to robots, nor do they want to, because they have a day job that's very important and takes most of their time. And so you end up in this space where it's really difficult to make robots and automation accessible in the scientific space. And for us, we started to look at this from the perspective of, how do we mediate this cyber physical problem, right? I have robots, I have people, and you can start to deploy software interfaces to help mediate that interaction and kind of build a digital cocoon around the lab itself. And so what we ended up in our building at Artificial is trying to solve this problem of when a scientist walks up to an automated system, they usually see it as being too complicated, so they walk away and run their experiment on the bench. But what if they could walk in and say, this is the experiment I want to run? We guide them through all the work that they need to do to set up for that experiment. And then we actually kick off the run on the robot and put all their experimental data back into the cloud for them to see. So to do that, I think I wanted to show some of these slides without getting too much into like products land, more because I think a lot of what we're building comes from the same ideas that I got to explore in chapter 1 through 3 of my life. And so this is like a digital twin of some of the devices in the lab. And we have like an editor where you can build out this digital twin really quickly. And something that, in Media Lab, we did a lot of was building out digital twins and simulation of the robots and their animations before deploying them in these environments. And so in this case, we ended up building a library where you could pull in all the equipment that you had in your lab. We encoded it in what we call common sense lab physics. So like, where can things fit? What tubes can go where? And really start to layer all this information that typically lives in the head of somebody who's an expert into an actual software digital system. And so it allowed me to kind of start scratching the same itches that I had in academia, but start to explore them in this more industry context. Other things that drew on similar ideas were this idea of semantics, right? So how do I refer to things in my scene that I have in my lab and start to build a language around it? And so with this, a scientist can go in and write the protocol that they're going to run in their lab using kind of a markdown language that we've been developing. So here I could go in and say, I want to load this device. I may want to fill a tube and do these kinds of actions on the lab itself. Other things that we worked on were really around how do you put together workflows that are hybrid. So this is something that drew a lot on state machines that we worked on in Media Lab, right? So how do I get a person and their interaction to be part of the same workflow as automation and its own interaction? So here you could go in and stitch together, like, I want this person to do a thing, then I want the robot to run stuff, then a person has to come and do another task. And I can start to bridge the world of people and robots in this very explicit kind of workflow way. And then finally, I think one of the biggest challenges that I've faced with robots in all applications has been inspectability, because it's really difficult to know what the system is doing unless you can start to show that to the user. And so we started using the same digital twins that we were constructing to expose this information back to a scientist as to like, what's broken? Does it need help? Do you need to come in and take any actions on it? And really start to emphasize inspectability in systems that have previously been black boxes to folks. And so, I say all of that really around this idea that I think the world doesn't have to look like the two extremes where, either robots and people can't interact, or it's that they're intimately connected, as I got to explore in the academic space. But in fact, it is possible to bridge in these subtle ways and start to use software and other tools as a way to mediate the nature of that relationship. So across these 4 chapters that I got to explore, I think a lot of the themes that are relevant to artificial today actually came from my experiences in chapters 1 through 3, and were very much emphasized in the academic work that I had the opportunity to do. And so for me, like really the next set of chapters of my life is going back to that same deep gulf of what robots can do today and what we want them to be, and hopefully like working with that community to lower the depth of that gulf, but also to kind of use these tools as a bridge across and try to connect that reality into what I hope is the way that robots and automation can exist in our world in our day-to-day. So that was it, but I will stop there for questions.
Okay, join me in congratulating Nikhita for the amazing presentation. I think it's very interesting and very relevant, this notion that you talked about how industry and academia are not closed doors to each other, right? You can go from one to the other and oscillate between them, and the problems that they face might be different, but still there are some bridges there, and I think that's very important for everyone. We are now open to questions. I would kindly ask Nikhita to stop sharing your screen, please. And we are now open to questions. So if anyone has a question, please just raise your hand or write in the chat. I have several questions for Nikhita. So the first one is always the most difficult. So I would like to give you a challenge, which would be if you could give one advice to PhD students which are currently unsure if they would like to continue academia or pursue some job in the industry, what would you tell them?
I would probably say, like, be very particular with the job you spend your time on. I think oftentimes when you're trying to make that decision, folks go and apply to everything that they can find that could possibly fit their skills. And what that does is that it forces you into this decision of like, I'm not really excited about some of these options, so I'm in this existential crisis of academia or industry. And I actually never applied to a job online. I only applied to 2 jobs. And every single stage of my life, even with labs, like I've been very specific as to what I applied to. And I think part of that was that I spent a ton of upfront time talking to a ton of people and connecting with them to hone in on like, what would be the day-to-day if I spent like 9 to 5 every single day doing this work. And what it allowed me to then ask myself in that decision was not, is it academia or industry? It was more that, is this job and the way that I spend my day-to-day how I want to spend the next year or next chapter of my life? So I do think that being very, very specific and particular and doing the upfront work is a great way to do that. And I think as an exercise, like what I ended up forcing myself to do is writing my dream job description every time I make a move. And so I write a thesis for like, how do I want to spend my day? And then I go out into the world and try to find someone who lets me and pays me to do that.
Okay, I think that's super insightful, because I think this is a problem that a lot of PhD students face. This dichotomy between industry and academia. Is there any questions in the chat? If you want to ask a question, please raise your hand. So I have several questions, because maybe I'm one of those PhD students unsure about the future. So one of the things that I found remarkable in your talk was when you talked about the stark contrast between the problems that you faced when you moved to industry and the ones that you had envisioned when you were in academia. So do you think there's a mismatch between what we academics are currently looking into and the problems that are faced currently right now? in the industry? And should academics perhaps focus on more concrete problems faced by the industry? Or do you think we should still remain with that 30-year-old long plan about the advancement of robotics?
It's a good question. I actually don't think that you need to pivot academia to working on those problems. And I think part of why industry looks the way that it does is not because of a goal misalignment, right? Like I think even industry wants to get to the same world that academia is trying to enable. It's literally like the kind of foundation problem of like basic things don't exist, right? Like devices are not connected to the internet. The infrastructure to be able to like integrate instrumentation doesn't exist. Drivers don't talk to each other. And like, I don't have software tools to deploy these kind of new ideas. And so I think a lot of the challenges have less to do with misaligned intention and a lot more to do with not having the foundations where they need to be. And I don't personally think that that's a burden that academia needs to take on because there's incredible value to exploring that future landscape. But I do think that, you know, as a set of folks in industry, there's a responsibility to help create those foundations so that a lot more of those academic pieces can make their way into real life applications. So that would be my kind of perspective on it, is that we need more people who want to work on what appear to be the non-sexy problems of like just connect instruments to each other and like get things to talk in ways that we need them to. So.
Okay. So you don't think foundations should be the focus?
I think academia has a place in focusing on intent, right, of where we're going. But I do think that there's a role in place for laying those foundations. Like there's so many, in many industries, there's been things like standard bodies, consortiums that have been formed through academic and industry applications. So I think there's many vehicles through which to get to those foundations. I don't necessarily think the answer to that means like academia has to shift its focus either, right?
Okay, thank you so much, Nikhita. I think that's very insightful. And we have a question by Bahar. Go ahead.
Thank you, Miguel. Thank you for the great talk, Nikhita. I was actually wondering, why did you choose starting your own company instead of working as part of like a bigger company, or instead of continuing to work as part of a startup?
Yeah, I mean, so I ended up founding the company by happenstance, I would say. I actually joined the startup very much with the intent to be a UX designer. And so I was mostly just intrigued by the possibility of building out a robotic platform that was more like horizontal across all these different applications. And so it was certainly not a planned activity. And then I think the 3 years after that kind of led to it being a company I co-founded and, you know, now I'm responsible for in other ways. But I think for me to, you know, the first part of your question around a bigger company versus the smaller context, I did weigh that a lot. Like I did, you know, I talked to a ton of folks at places like Google X or, you know, like Amazon and sort of the larger entities that I could find. For me personally, like I wanted to be able to wear more hats and kind of define I think part of it comes to, if you are part of a larger company working on a robotics problem, a bunch of decisions have already been made, right? Like the robot looks the way that it looks, it's been built, and then you are coming in as a UX designer to study how to make that interaction a little bit better, right, day to day. If I get to control the nature of that robot and how it works and the, you know, like more about it foundationally, then I feel like I'm getting more intuition out of the results that I see in the world because I constructed the problem in addition to playing with it. And so that for me was the reason I wanted to be in a smaller like startup context, was like, I want to trust the intuition I get from this experience versus, you know, in getting to like work on someone else's vision and then adding my little bits that I could. But that's sort of how I felt at the time.
It makes a lot of sense. I was also wondering, what was the biggest challenges you faced transitioning from academia to the industry?
I would say like constraints, right? Like creating them. I think in academia, the nature of constraints that you're creating is very different because you're scoping your PhD or you're scoping your master's thesis and you want to go deep in that. And so you create these upfront constraints and then the world is your oyster to go deep in whatever way that you want to, in a sense. I think the flip side with industry is that you can have an amazing idea, but if it cannot be executed subject to like financial, team, and other resource constraints, it'll never see the light of day. And I think that's an appreciation that I didn't have when I first started in industry, that like the nature of those constraints is actually quite different. And so the idea matters and is valuable, but unless you can execute it within a time frame with the limited set of resources that you have, then from an industry perspective, it ceases to hold value. And so I think that shift in value equation was like definitely a big one. I think the other challenge I faced, and this was fundamentally related to like fundraising, right? When you go and talk to, you know, VCs in the world, there is a very different perspective on nuanced ideas, right? Like anyone who is trying to generate capital will want an idea that, you know, you're already making 10 million a year. Here's my revenue. Here's my path to like the perfect, you know, process with this company. And I think ideas that have more complexity to them, the storytelling you have to do to make it simple, to make it approachable, and to paint a vision is like puts a lot of burden on you as the creator. And so I think getting to like learning how to tell that story was definitely like the second challenge, I would say, is like, how do you get people to buy into your vision, basically?
I think we're kind of doing that within the papers, but I guess it's on the bigger scale. We're trying to sell a story to get money instead of just acceptance. Thank you very much.
Totally. I think like, I actually think the experience of like writing papers and giving presentations at Media Lab was probably more informative for me in that way than any time I spent in industry, right? Because it's like you have a ton of complexity and you need to make it approachable when someone comes to give you a grant or anything like that. So yeah.
Thank you so much for your question, Wahab. So we have a couple of questions in the chat. One of them is by Saish, and the question is, what type of challenges did you face when checking the feasibility of robots in the industry you work? And I kind of would like to add to that question, which is you already have some experience in the industry of robotics. And what do you think are the biggest challenges that the automation industry, especially robotics, are currently facing, in your opinion?
Yeah, I mean, I think there's a few, right? So one, and this was the like kind of the basis of the company earlier on, is that if you look at a robotics startup today, they all reinvent the exact same software stack like over and over and over again. So I do still think that that is like a core problem. And if you think about like app developers, an iPhone or an Android developer was not a career like, you know, a decade and a half ago, right? And then it became a career because we built the foundation such that someone could just focus on the application and go build the app without having to worry about everything else related to getting it to run. And I don't think we're there with robots yet in industry where, you know, people can focus on the end application versus focusing on all the other foundational platform bits that they need to. And what that means is that in industry, all these robotics companies burn a ton of money and capital and resources like on just getting to that point, right? So by the time they can even build their application and put it into the world, they've already spent like 2-3 years doing work that, you know, could have been done by someone else in a standardized way. So I think that's like a big thing preventing robots from being in more like applications in the world. I think the other part when it comes to feasibility, and I certainly think we still struggle with this at Artificial, is like, how do you take real applications? So you're building for all these customers and you want to say yes, right? Like you want to say yes to, I will get your robot to do this thing. And I think that's like a mindset that is very easy to have in academia, because when someone gives you an intellectually challenging problem, your instinct is to be like, absolutely, I will make this robot do this thing. And I will spend my entire evening in the basement getting it to do that. But when it comes to industry, like you don't want to go into the conversation with that intention because you want to build things that are generalizable. So will exist for like all 10 of these customers, and you can somehow build into a product feature. And so I think that lens is very different than kind of wanting to like just make the robot do the thing that someone really wants it to do or is intellectually challenging. And I think that's still something that we struggle with. I think many companies struggle with, is like, how do you balance you know, the forward-looking, cool, like awesome technical feature alongside things that are actually generalizable across many, many, many use cases.
Okay, thank you so much. We have much more questions in the chat. So one of the questions is by Ali, and Ali is asking, what do you think are the important features that the researcher should have to help them move to industry? So do you think there's any type of features that the person itself should have?
I mean, I think it's like a tricky question because it depends on where you want to move in industry, right? Like, I think if you want to be a research scientist and go deep within your expertise in an industry context, which I have many friends who've gone on that journey, I think it's more about continuing to hone your craft, right? And so then you want to be the person who's an expert at like X or Y. And so I think it becomes like an extension of academia, but more in the industry context. I think if you want to take what you did in academia and turn it into like a company or work on things in a more kind of general way, I think that really, like, I've had a lot of friends go about that either the startup route or becoming like a product owner at like a robotic kind of company. I think the thing that we've all resonated on is you have to be willing to let things go, right? Like I think when you've done the intellectual depth and you understand it, you have this desire when you're like playing that role in industry to be like, I want this robot to be perfect. I see how it can be. I could even probably write the code, but like, that's not a possibility in the case of constraints that I have. And so being able to like check yourself on what is actually intellectual fascination versus what like will add, you know, demonstratable value to an end user, I think becomes a tension that you have to navigate. And so being able to let some things go, I do think has helped a lot for me and like many friends who've had to deal with that tension. So.
Okay, thank you so much, Nikhita. We have a couple more questions. So Saish is once again asking for your industry insights, and he's talking about how is the response, since you deal with stakeholders and industry related issues, what is their response to robotics, or so to adopting these platforms to perform tasks? Do you think there's a big widespread acceptance of that idea? Do you think there's still some constraints about that? Do you think it depends on the type of use of the robot?
Yeah, I think it's all over the map for sure. And so like, to give you an example, like, you know, like we have one customer we work with, and their like head of automation obviously loves robots, right? It's like he's a reformed scientist, as he jokes sometimes, who became a robotics and automation engineer. And so he loves them, but then, you know, like a director of science type person at their company like named the robot after the villain in The Little Mermaid because she doesn't believe that robots need to exist, right? So even within like one ecosystem, I think you can end up with very contrasting opinions. And I think they come from different places, right? Like there's the obvious one, which is like, will robots take over my job kind of problem. And I think that is something that you can navigate through talking about your philosophy, about where you put people, and like it's about empowering people. I think the other one is also like a lack of trust in robots itself, right? So if you've done all of your experiments on the bench, or you've always done things a certain way, why would you trust this machine to do it better than you? So I think that kind of tension requires like, you know, talking to customers and educating them and like building ways so that they can see what's happening and start to trust it in a way. But I think oftentimes the discontent comes from either trust or kind of a you will take over my job type of like reluctance, I would say. But at the same time, like I think there's like I've also encountered a ton of people who are just excited about the potential. And so they're usually the ones you make into your champions, I would say. So.
Okay, thank you so much. It's very interesting to have, because those problems happen not only with stakeholders, but I think with general population, right?
Yeah.
We have another question by Francesco, and he asks, in your opinion, how difficult it is today to go from having an idea of a robotic application in business to actually starting and building your own startup?
Yeah, I mean, this one's close to home, I will say. So I would say it's very difficult, but I think in a good way, right? Like I think there's a bunch of things that make it difficult. So, you know, starting in the beginning, like the beginning parts of it, like I have an idea I'm going to like go out and try this. I think that's very much like a personality thing, right? Like I think I have friends who struggle with that and will take forever because they're like, I want it to be perfect when I start. And then I think I have other friends who've been more like willing to say like, yeah, I'll just run with this. It'll probably change 50 times. So we'll see what happens. So I think that early phase is really like a personality like tension of like, you know, how do you go about these type of challenges. I think the rest of it of like, you know, getting capital, of like working on the problem, going through the ups and downs of it, I will not sugarcoat, it is not easy, but I do think it's like, if anyone can be prepared, I would say a PhD student is probably well prepared given the exposure that I've had in my limited time as like a master's student and all my friends. Because I think it really is like, a lot of it has similarity to you go heads down and you work on something and then you come out for air, and then you go heads down and work on something and you come out for air again. It looks pretty much the same. So I think actually the Media Lab probably prepared me very well for the ups and downs of having a company. So.
Thank you so much for not sugarcoating the problem. I think that's very good as well for our audience. Duncan also has an insight from the UK. So it says that the government supports the development of new technology in academia and in the industry, and you're expected to work together in technology clusters, usually around universities or high-tech companies. So as an academic, it is impossible to design or to translate without involving an industry partner, which I think it's a very good. I don't know how it actually works there in the US, but I think might be something similar, right? Regarding the involvement of universities and companies.
Yeah, I think there's certainly like areas of intersection, right? Like when I was at the Media Lab, I worked closely with like BOS and other companies on our projects. And I think it adds like a realness to what you're working on in a different way. I don't think it always happens, but there's certainly like a ton of opportunities to do it. So, yeah.
Perfect. So we are running out of time, unfortunately. I would just like to end also with this comment by Marcos, who says, I love your notebooks, which is absolutely true. So I would invite everyone to check Nikhita's notebooks in her website because they are absolutely amazing. And once again, let me congratulate you for the talk and for the discussion, because I think it's very, very, very important for our audience that are usually young PhD students and researchers to understand that going to academia is not a one-way street, that there are returns and you can oscillate, and the problems that they face are different, but still it is possible to collaborate between these two spaces. So I think that's very, very interesting. Thank you so much, Nikhita, for the presentation and for the discussion.
Yeah, thank you for having me and for all you guys.
So for more questions, we have a Slack channel for Nikhita. If you want to join us just to answer some extra questions from our audience at your own pace, you can do that. And just before we close this session, I would just like to talk briefly about the next speaker, which will be in about 2 weeks. So in 2 weeks, we'll have Daniel Brown. Daniel Brown is a postdoc from the University of Berkeley, and he'll be talking about how to leverage human input for robust robot learning. So you better not miss it, because I think it's going to be very, very interesting. And having said that, I would like to wish you, and before that, I would like to thank our sponsor, Animatus, And having said that, we'd like to thank you for attending this session, and we'll see you in 2 weeks.